Hello, could you hear me?
Yeah, good morning, sir. You're audible.
Yes, sir.
Okay. So, um, so how do you want to go about with today's session? I'm giving you the option. So you would like to review some topics, solve some problems, or whatever. What is that you would like to do? Something, some topic that is not clear, and you would like to have a detailed discussion. Uh, am I audible to you guys?
Yes, sir, you're audible.
Yeah. So please tell. So it's up. It's yours. So I have like it's the day is yours. Whichever way you would like to go ahead, we can do that. So some discussion on particular topics that's possible, some problems or the type of problems that you would like to solve, or if you have something to discuss, that is also possible. And last 10 minutes I will take. I generally in every class I would ask what's the general discussion bar feedback regarding the course to have a generic update. So that maybe the last maybe 10:45 to 11 we can do that, but mean all the intermediate time we can do whatever way you would like to. So first of all, from start to end, any point that any topic that require a reconsideration, something that is not clear, the most probably the toughest. Do you want me to?
Sir, when we shorten the closed loop systems,
Uh,
it was like we had this question in the tutor as well, tut 7 question 1. So, sir, therein we were able to see the solution and then figure out, okay, it's working this way, but we were not being able to, while discussing with my friends also, we were not being able to figure out how, if it comes in exam or if we have a general question, how we'll be able to shorten it ourselves.
okay, so I understand. So basically that trick how to master, is that the technical thing? Is that something you are asking for? So how to do this trick?
Yes, sir.
Okay, maybe let's take one example. Maybe the tut question itself. Hmm. So is this agreeable for a point of discussion now? Hemant, Harshita, Ashutosh, Aranya, Dinesh, Ishika,
Yes,
and
sir. We can do that.
Paul. Okay, so what I will do, I'll give you an interesting problem. You try to yourself and tell me whether you are able to solve it. Is that okay? Small problem. It would hardly
Yes.
take minutes. Okay.
Yes, sir.
Okay. Just give me a minute. Let me pull up. I'm sharing my screen, okay? Could you see this?
Yes, sir.
So now maybe, so I think the best way to learn is through discussion. So maybe you take some 10:08 till 10:15, you guys maybe try out, or maybe a couple of minutes more. This is a very simple example. So this would give you a perspective, but as you told, this is not a straightforward example also. Correct? So just try solving and let's discuss afterwards. Is that okay?
Yes, sir.
Okay. So please try yourself, please. So we'll rejoin at maybe 8 minutes from now, which means close to 10:17 or so.
So we have to find the transfer function that relates C and R, right?
Yes, yes. So the what you call set point to output.
So where have you uploaded the flipped lecture?
It is it's like any other lecture. It's just there in the Teams. Can you check? Probably the last video. Can you check and tell me right now, maybe, so that I am.
Yes, sir, it's there. I have seen.
Okay, that's it. So it's like the last. So probably the last video. I just recorded it in the Teams itself, so that everything would. And also, may I request someone to give the repository of my link so that at least I will have a copy of those. So it is there in the class material. It's the same thing.
What, sir?
So see, my recordings, right? So the class recording, so various days, what I have been teaching. So I don't have a copy of that. Can I get? So it is there inside the file recordings. This is the same thing.
Yes, sir.
Okay.
Yes, sir. I found the flipped lecture as well.
Yeah. So maybe you can bookkeep it properly. I don't know. So I just recorded it and left it. That's all. See, I hope all of you at least tried out. Is that so?
Yes, sir.
Yes, sir.
So someone of you can. So I will unshare my screen. Somebody who has at least tried completing or completed can share and explain how they have approached the problem. Any of you?
Sir, I tried with the back calculation method.
Whatever. So that's okay. You can share your screen and explain how you have done so that others.
Sir, I don't like I have written on my like copy or some rough paper. So
No, that's okay. So then what you could do would be just do a photo and share in the chat maybe.
Yes, sir. I'm doing that.
No, I can share my screen, but I'm saying so let's you guys discuss. It's better that it's always discussion helpful rather than I explain the solution. And I would also suggest something more. If you need, so I think, so when is our exam? It's on the 20th, right?
yes, sir.
So we can, and okay, so are you guys would be meeting? So are we meeting on Friday as well?
So
Sir,
this is actually the Friday timetable.
yes.
So it's done, right? So this is the last business, basically. Okay. So my question to you is, I can have one more informal session to, you can say to whomsoever you want, okay? If you, like, I don't know how is your timetables are placed, and if you're reviewing and some problems are finding difficult, we can have one more informal meeting, but I think you guys schedule it and invite me if needed. So for instance, some problem is difficult to solve, you just kind of, so there are multiple, very good. So yeah, so Visuddha, have you done with the solution? Then you can explain. So I can explain you the answer. The answer would be G plus H1 by 1 plus GH2.
Yes.
Is that you?
Yes, sir. I'm getting same also.
Okay, so then I think what is the problem? So you are all right.
No, sir, like for shortening it, like in Tude question 1, the diagram was very complex, and then we reduced some of the branches, we rearranged.
This is actually the simplest thing. So you do it piece by piece now. So come down.
Yes, sir.
No, RH1. Okay, come down last. Come down. GH1 by 1 plus G. Okay, so this is like you do step by step. Okay. So if I were you, I will try. I will do a mild trick. So anybody has solved this problem differently? It's a classical way of solving this problem. Anybody has solved this problem differently?
So I tried to simplify the branches.
Yeah. Please share your screen.
Okay, sir. So is it visible? Sir?
It is. It is. So you're also getting the same answer, right? GH1 or is did you?
So this is the which I got, sir.
So is it matching with the final answer G plus H1 by 1 plus GH2?
Yes, sir.
Okay. So you explain how did you do it?
So first what I did is, sir, I tried to uh, remove these things at here so that I can do some like parallel addition. So,
Perfect.
so what I did, I just tried to find out what is the value of y1.
Mhm.
So, so I calculated it here, sir. So is my cursor visible?
Yes. Yes.
Okay, so I got the y1 as r of s by 1 plus gh2. So what I did, I tried to find a new function such that
Absolutely.
from rs I can get it the same value of y1.
Absolutely. Yes. This is
So
another nice way of doing it. Yes. Go ahead.
later I just did this addition, sir, and I got c of s. So this is c of s, sir. I
Okay.
just mistakenly wrote that.
So everybody got what she has done. Prashita, others. Ananya, Dinesh, Naveen, Isuta, Hemant.
So over here I just wrote y1. I didn't change it to c of s, sir.
Absolutely fine. Did you get what the steps that he has done? Everybody is with her steps.
Sir, how was this shortened? Could you please do it again on
Yes.
the
Okay.
board?
Yes. So just explain again, maybe. So I'll show it third way of doing it. So that's a different thing. But this is also a nice thing.
So shall I explain again?
Yes.
Okay,
So
sir.
Sudha, you can directly ask what is the problem. Or
All right, sir.
So basically what I have done, I tried to find out the y1, the result after doing this addition, and I got that y1 is nothing but r of s by 1 plus gh2. So later I tried to cut this connection and like get it from r of s directly, since in the end y1 is nothing but in terms of r of s. So I just changed the transfer function by doing some addition, like I find out the x value, like the new transfer function, by just equating the y1 with r of s plus, sorry, r of s minus, okay, so I just did plus here. I didn't do the minus thing. I just did the s. And after I got x as minus g of h2 by 1 plus g of h2. And I just put that the transfer function over here. I don't need to keep the minus sign since there is already a minus over here. That mistake I did. Okay, and after that what I got as y1 is just by adding these two, and after that multiplying this h1 plus g, I will get the c of s.
sorry, is this fine now? So
Right.
I'll now
Right.
so use share. I'll show a third way of solving the same problem.
Okay.
This is probably the easiest, I would say. There is basically nothing to do. So what I have done, so this is the question, right? So let me also paste the question on the top of this. Wait a minute. So let me put it over here and I am pasting the question on the top. Could you see now? All of you?
Yes.
Okay, so what I think I think this is one another way of solving. It is very similar to what she has done. So what we are doing, see, so there is a branch that going to H1 and connecting HCS. So the problem here it is a bypass loop. If it is not a bypass loop, then it would have been an easier way to. So the problematic loop here is this loop that goes to H1 and going to that plus sign. If it is not there, it is decoupled. You see, this is a very simple problem. So how to do that? So see, your H1 is going there and adding. So this whatever is coming in over here, okay, is going to G and is also going to H1. So what I could do is I can cut. So let G goes over here, okay, and whatever H1 which should have been gone by H1, I can multiply with H1 by G so that to decouple its effect and just as an additional plus loop over here. So now what happens? This is now in the standard form. This is just an additional form. So this you know how to simplify G by 1 plus GH2. This is fine. And now you look at over here. Here G is reaching and G times H1 by G is also reaching. So it would be one total effect would be 1 plus H1 by G. So these would be now two parallel, rather two series transfer functions which you can directly multiply. Is this clear? Is this clear? Yes.
So can you explain that H1 by G part?
Acha. So let me just check. Okay. So if you look at this, the end loop, now what all things it is going over here. Okay, so if you put a light here, it's S plus S1 is getting added, S plus G1 is also getting added. So now see the summation. So what is happening? So the G is taken feedback and coming back. So that is why this point is also going over here, and this point is also going over here. So if I would like to say, if I would like to cut this guy down, so if I take this over here, so what is that GH1 would be the output at just before the plus, right?
Yes, sir.
So, but I don't want that. So GH1 is not really what is going here. So what I would do is, uh, but because the effect of G is not here at this point when the tap is taken. So whenever I take a line from the A, you see, so I don't know whether you see my cursor here.
Yes, sir.
So yeah, so the G is already coming over here, but when the original tap of which is taken for H1, G is not there. So what I could do is, when I take a tap line from here, okay, H1 is already there in the line, but I don't want the effect of G1 because whenever the initial loop was taken, there was no G, so I will divide by G. Is that clear to all of you? Any confusion? Okay, once more. So look at the first point. So whenever the H1 line is taken, there is no G effect here. Agree?
Yes, sir.
So let me just keep this phone in the silent mode. Give me a minute. Okay, so what you really need to do, you need to isolate this feedback loop from the line so that at least you will get GH2 as a nice feedback loop. Is that agreed?
Yes, sir. We understood.
So now if I need to move the tapping point, so let me just see if I can do with the help of some draw. Is that possible? Yes, something. If I need to move this from here, move this to here. So, but when the original line, when it comes, it's already multiplied by G. But when the original, so but the first initial tap, when it is taken, there was no G multiplication. So if I started tapping from here, I don't, so the effect of G is already accommodated, but the original line does not have the effect of G. So what I should do, I should divide by G.
Yes, sir. So since we can see that the line that is coming into this one is already multiplied by G, we are dividing it by G once again so that we can get X1.
So now what happens, this loop and this loop are isolated. Is this making sense to all of you?
Yes, sir.
To ask the question, it was Hemant.
Yes, sir.
So is this clear now?
Yes, sir.
And one more thing.
Go ahead, please.
So when we have this closed loop, it is clearly visible that from Mason's rule also we can get G divided by 1 plus GH2 as a
Correct.
function here. But sir, in this the other loop, how are we applying Mason's rule? Can you please explain?
You don't have to apply Mason rule. You can apply if needed, but if you don't want to apply, that is also fine. Okay, so let's just give me a minute. So okay,
Sir, other
so
loop is just a parallel to transfer
huh,
function, so we can add them.
yeah, you can add it. What I am trying to say here is, so see, one is G, okay, other one is H1 by G, correct? So uh, so G's effect should be anyway accounted, and H1G. So see, if you put a point over here, so this is, let's say, your reference point. So this reference point, two lines are going to the summation loop. One is the G itself, okay, okay. One is this loop times H1 by G. So whatever be the case, so not Gx. So let me just erase this little bit. So whatever this point. So let's say this point is, let's say if I call it E, whatever. So here E is coming in, plus E times H1 by G also. So you take the E out, of course E is not there, so it's an internal point, so you can just leave out. So 1 plus H1 B is the cumulative effect from this point to this point. Is this agreeable?
Yes, sir. Understood.
So I'm saying it's better to use strict Mason-Gaines formula, as I told, when you have the comparator minus, that is quite straightforward. Otherwise, it's always better to have a. So if you so if you still want to use a Mason-Gaines formula, how do you do it? If you're really confused about using a Mason-Gaines formula, how do you do it?
Sir, isn't Mason's rule for closed loops only?
No. No, I'm saying, so see,
The
forget
second loop
about.
is not closed. Both are like pointing to one direction only.
Closed.
So what I am trying to say is, so let's say, so if the Mason's gain, if you are given a closed loop, and Mason's gain formula is also used when you have plus and minus. If you have both pluses, how will you use Mason's gain formula?
Sir, we will just replace the minus, the plus in the denominator by a minus.
So that is one way. So simplest way. So I'm saying, so whenever you have this plus plus, you apply it directly. Otherwise, you put a minus over here. And but here, as you rightly pointed out, that this is definitely not. It's a open loop business. So you have to just count the total effects coming out of it. Is this okay?
Yes, sir. Sir, can we please discuss Tute 7 question 1 once?
Let me unshare my screen. Just give me a minute. So Tute 7.
Question 1.
Hold on. Am I audible to you guys?
Yes, sir.
So that's a complicated one. Share that. Oh, tell me now what's the problem?
Sir, when we shorten this, uh, sir, if you could just open the solution PDF as well along with.
Go ahead.
Sir, we see that in the first one, the first diagram, we can see that E is equal to YSP minus Y plus Y2.
Why tilde too, actually?
Yeah, Y2 tilde. So in the second diagram, we see that we have not conserved E. We have changed its definition only. So if we just scroll down a little, we can see that E is now equal to YSP minus Y. So how do we know what we can preserve and what we cannot? How, matlab, when we are doing it ourselves, we wouldn't have thought of it ourselves that we can change E like this.
So see, so the basic thumb rule in closed loop diagram reduction, you with the so the except the endpoint YSP, D, and Y. Okay, they are all internal to the system. So YSP you cannot touch, D you cannot touch, Y you cannot touch because they are internal, they are external.
Right.
Agreed.
Yes.
So anything internal is a matter of convenience. That's why we are able to reduce the block diagram because it's up to our convenience, right? It is not a rigorous definition, but the definition on YSP, D, and Y is enforced externally. So what I am trying to say is, when you try to do, so there is no limit for defining and redefining anything inside the loop except these three endpoints. Are you getting it?
Yes, sir.
So you are free to do anything, but don't touch YSP, D, and Y.
So,
Yeah.
so can I change the comparator signs also?
So here, so you're talking about this plus instead, you can make it minus. Is that the question? Instead of minus,
Yes.
you can make it plus.
Yes, sir.
You can, but you have to properly accommodate the transfer function correctly. So just to, for instance, if you look So this y1 minus y2 tilde you check. Okay, it is going as minus over here. If you would like, if you can make it a plus, you should put y2 tilde minus y1 tilde. So look at the comparator that is lying between E and E prime. Okay, it is E is coming as plus, y1 minus y2 tilde is coming, y1 tilde minus y2 tilde is coming as minus. So this is because, and if you make it a plus, you have to properly accommodate the feedback loop such a way that there is a negative term added to somewhere here. So you can change, technically there is no problem, but that you will have to accommodate the sign change somewhere inside.
So if I have to change the minus as plus, then the transfer function which is coming, like for example here the g tilde into 1 minus e to the power minus theta into s, I have to multiply it with a minus sign, right?
Correct. So I'm saying internally, so see, this is a very, I would say this is more of a, okay, so to give a perspective, this is block diagram reduction. So this is a standard problem people use in circuit theory. Circuit theory. So as I told, this is a very wide spectrum of business. So whatever you solve, your friends in the electrical engineering might have solved in circuit theory in different formats. So they would have, in that case, they don't have transfer function. They would have maybe load profiles or something like that. So only thing that you need to apply the basic principles. External points cannot be touched. Okay, if it is a closed loop, blindly apply Mason's formula. And if there is a loop which is being bypassed, if you could properly accommodate its effect, what you call adding or compensating, you are free to. But don't miss anything technically. So see, from an external point, only y, sp, d, and y has to be kept sacrosanct because rest all inside you can modify. That is why we are doing a block diagram protection. Because whatever placed inside is all for our convenience. Are you getting what I'm trying to say?
So in the end, whatever value we have to get, like before the block reduction, it must be same after doing the reduction also. That's the
Yes,
thing.
absolutely. Yes. This is just a convenience, just a matter of convenience.
So in the between, the values of p, e prime can change.
Whereas P and E prime can all change. Yes. So see, so it is like this, no? So let's say so your name, I think Harshita, right?
Yes, sir.
Harshita and Visruda have been hired to define a control system. Okay, so so your company would say, so this is my YSP, this is your, so this is the set point that you need to reach. This is the disturbance rejection that you're going to, sorry, this is the disturbance that you're going to face, and this is the output. So based on your input, so you design it one way. Based on her insight, she will define it some way. Only point is the relation between YSP, D, and Y should be uh, kept untouched. So as I whenever if you do it in a different way also, this relation should be kept intact. Are you getting my point? This is the way you design. So that is why it has become reduction. No? So it's all our convenience. But it won't alter the fundamental relation between YSP, D, and Y. Are you getting my point?
Yes, sir.
Okay. So any other point on this? Do you want to solve one more problem in this genus? Anyone? Okay. So since I am not receiving any feedback, maybe I will generally ask you let's ask something, discuss something non-acad. Okay. So what do you think the course, and how do you feel, and what do you think, like, so some generic inputs you could give. So let's I'll also switch my video on. If you could also switch on the video, it would be nice. Let's have a 10 minutes free session. Hi, Hitosh.
Hi, sir. Good afternoon. Good morning.
Yeah. All of you others, please. Let's have an informal 10-minute session. Stop the recording. Oh my goodness, you are traveling somewhere?